All right, here we're looking at our notes for section 2.5, and we're really dealing with compound inequalities in here. So compound inequalities are these inequalities that have either an and statement or an or statement. So this is really the sheet we're going to be using today, so go ahead and get that out. You do really need a couple of colors with you today. I'm going to go ahead and use pens today because we're going to be circling and doing them all kind of together. So that's just going to be how we're taking our notes today. Okay, so the first thing is we're going to look at some and inequalities. And of course we're going to be graphing them because that's really where we're living, is graphing them. So when I see an inequality just like this one and I have an and, I go ahead and I solve them separately. Okay, so here I have negative 2y is greater than or equal to negative 8 and y plus 3 is greater than 2. So I'm going to go ahead and solve this first one in purple. So to undo this multiplication, I divide by negative 2 and I divide by negative 2. Why? Here I was a negative, I was dividing by a negative. And remember, when I divide by a negative, my sign switches. So is less than or equal to negative 8 divided by a negative is positive 4. Okay, so we're going to go ahead and kind of make our number line. Okay, so here I'm going to graph in kind of two colors and we'll see what our final graph looks like. Okay, so here I have it's less than or equal to 4, so I know I have a closed circle on 4 and everything is shaded in this direction. Okay, so now I'm going to use a different color and I'm going to go ahead and use green and solve for this one. So I see I'm adding here, so to undo that addition, I subtract 3 from both sides. So I have y is greater than negative 1. So here I have that open circle since I don't have an equals at negative 1, and I see I'm shading to the right. So since this was an and statement, I want to go ahead and finally mark wherever my graphs overlap. So the and is the overlapping piece. So I see I'm going to have my final graph. I'm going to have an open circle at negative 1 and a closed circle at 4, and my graph is shaded in between. Okay, so that is my final graph and my final solution for this. So I can go ahead and write that as well. So negative 1 is the smallest place where they overlap, and that's an open circle, and then my variable, and then this was a closed circle at 4. Okay, so that's going to kind of be how we're writing our final answers and how we're graphing our final answers. Okay, so now let's look at this next example. So here it's not written with an and in between, but I can do the same thing. So the first thing is I see I have this inequality right here. So I have negative 3 is less than or equal to x plus 2. So let's go ahead and solve that one. So I see my x is on that side, so I'm going to subtract by, because I want to undo what's being done. So I have negative 5 is less than or equal to x. Well, I like having my x first, my variable first, so I'm going to switch the direction. So my x was by the big side, so it's by the big side again. So there we go. So now I can go ahead and I can graph that one as well. Okay, so again I see x as greater than or equal to, so closed circle at negative 5 and everything is shaded to the right. So now the second inequality is I still have that x plus 2, but now I use my second inequality piece of it. So now I have x plus 2 is less than or equal to 5. So to undo that 2, I subtract from both sides. So x is less than or equal to 3. So now I can graph this piece as well. So it's going to be a closed circle, 1, 2, 3 at 3, and everything is shaded to the left. So again, since this is written this way, this is an and statement. So I want to go ahead and mark where my graphs overlap. So it's a closed circle here, and they overlap here, and a closed circle here. So now I can go ahead and write my final solution here. So it's negative 5, closed circle, so I have that equal to, x, and then closed circle, so equal to again, at 3. So my graph and my equation kind of go along together. So here we've got our final little example here. And again, I don't have it written as an and, but this is another way. So here's my purple side. So negative 8 is less than negative 2 times m minus 1. So always I want to get rid of my parentheses first by using my distributive property. So negative 8 is less than negative 2m plus 2 because I'm distributing that negative 2. So now I want to solve for my m. So to do that, I undo my any addition or subtraction first. And to undo this addition, I subtract. And then I want to undo that multiplication. So to undo multiplication, I divide. Here I'm dividing by a negative, so my sign is going to switch. So I'm going to have m is on my right side, but my sign changes direction because I am dividing by a negative. And a negative divided by a negative is positive, and 10 divided by 2 is 5. Again, I'm going to switch this just because I like to have my variable and then my symbol and then my constant. So I have m is towards the point 5. So let's go ahead and graph that one as well. So there's my 0. So there's negative 5. So I see that I have m is less than, so it's an open circle on 5, and it's going to be shaded to the left. Okay, let's look at the second piece of this inequality. So negative 2 times the quantity m minus 1 is less than 6. So again, I use my distributive property, and then I solve for my m. So I undo my addition or subtraction first, and then I undo my multiplication or division. And here again, I'm multiplying, or I'm dividing by a negative, so my sign switches direction. So m, my sign changes direction. Positive divided by a negative is a negative, and there we go. So now I can graph it, and I'm in the right order. I have my variable, my symbol, then my constant. So at a negative 2, I have an open circle, and I shade to the right. So I can see that my final graph, I have an open circle, and it's shaded, and then an open circle. So then to write my equation from here is I have a negative 2 is the lowest piece, open circle, so I don't have that equal sign, open circle, so I don't have that equal sign at 5. Okay, so I have my final answer. So now let's looking at solving these OR inequalities. So when I have an OR, that means any place that it's shaded at all. When I had that AND, it had to be where they were both shaded, but now it's a little more simple than that. So here I'm going to start, so I can solve both of these just separately. So I undo my addition or subtraction first. So 3p is less than 9. And then I undo my multiplication or division. So I have p is less than 3. So then I also have to solve this part. And this is just a more simple one. It's a one step. I'm dividing, so I go ahead and I multiply both sides. I'm multiplying by a positive, so I don't have to change the direction of the sign. So then I can go ahead and I graph them. And I see they're both positive, so I'm just going to start my graph at 2. So if this was an AND statement, it would have to be where they overlap. But because this is an OR statement, it's the entire thing where either one of them is. So I see that p is less than 3, so open circle on 3, and I shade to the left. And p is greater than 8, so open circle on 8, and I shade this direction. Okay? So if this was an AND statement, I would have no solution because they don't overlap at all. But an OR is where either of them is, so that I can finish my graph just like this. Okay, so now let's go ahead and solve this next one. So again, I just solve by undoing. So I have 5x is greater than or equal to 10, and I divide both sides by 5. Again, it's a positive number, so I don't have to change my sign. And then here's my OR. I see I have parentheses, so I want to undo those by distributing. So I've got negative 3x minus 12 is greater than 9. I add my 12. And then I divide. Here I'm dividing by that negative, so my sign switches direction. And then I've got a negative 7. So again, I can graph all of these pieces. Just like this. So my first part of my graph, x is greater than or equal to 2. So it's a closed circle, and I shade this way. X is less than negative 7, open circle, and I shade this way. Okay, and again, we've got an OR, so I can leave both of them just like this. And here's my last little example. So let's get these solved, okay? So we have to undo our addition or subtraction. So I've got 0 is less than negative z. Well, here I have a negative variable, and I don't want to deal with that, so I have to undo that. So I'm really, oh, and I'm subtracting 1 here, so it's a negative 1. So to undo this, I would multiply by a negative 1, and I'm multiplying by a negative, so I switch the direction of my sign. So 1 is greater than z. Okay, so I'm going to switch the order of this, so z, and then is towards the point, and then my constant. Okay, let's solve for this part. So I undo my adding or subtracting first. So 3z is greater than 6. And then I undo any multiplication or division. So z is greater than 2. So now I can go ahead and I can graph those and see what they look like on our number line as well. Oh, this was a positive one. I'm sorry. So this is now a negative 1. So if z is less than, it's an open circle, and I'm shading this way. And it's greater than, so it's an open circle, and I shade this way. Again, it's an or, so I can do that. Okay. So now here we're going to look at just what, now that I have a graph, how do I write my equations from that? So we're going to say that left is our starting point, and right is our right point. And then here's kind of how we follow this, okay? So I'm going, if it's an and, we saw those written together here. So here I'm going to have my left and my right and my variable in between. So then I either have this way, and you'll see that my arrows are going the same direction here. So when it's an and, we generally have the same direction. Okay, so when it's an or, I usually have left, and we always want to go in the right order. So x is either greater than, or less than our left point, or less than or equal to, or x is greater than or equal to our right point. The biggest one is that or statement. So now I want you to try a couple of these. I'm going to do this first one for you, and then I want you to see where you can go from here on these. So now we're going to write it from our graph. Here I see that the graph is in the middle between 2 points. So I know that this is going to be an and statement. So I see that the lowest point, the leftmost point, is negative 1. And I see that it's a closed circle, so I have that equal to. The greatest point, I'm going to put my variable, is 3. And again, it's a closed circle, so I have that equal to sign. So that's it. That's all we have to do to write that inequality from there. So I'm going to go ahead and do this one as well, because this one's an or, because we can see that it's going in both different directions. Okay, so I'm going to say, and I'm going to use x as my variable all the time here, just makes it a little bit easier. So x is, this is an open circle, so there's no equal sign, 1, or, right, we decided this was an or statement, x is greater than or equal to, because it's a closed circle, 4. Now I want you to take a couple minutes and kind of write your equations from these other 4 graphs. And now that we've got this all, now this is the extent of our notes for that section 2.5. So in your notebook, after we've stapled our stuff in from 2.4, this is going to just go on our next little page. And we're going to make sure and label everything so that this is 2.5. So now we've walked through compound inequalities using that and or, and just solving them and taking our multiple steps. So now I want you to go and work on your homework, and as always, come find me when you get stuck.